Welcome all. Today we are going to discuss another good and conceptual problem. And the question says that a semicircular ring of mass m and radius r is released from rest in the position shown with its lower edge resting on the horizontal surface. The minimum coefficient of static friction needed to prevent any initial slipping of the ring is x by 10 and you have to find the value of x. So here you see, first of all, suppose there was no friction. What do you think? What would have been the direction of slipping of this point? You see, here center of mass is somewhere here. We know it. It will be some inside. If there was no friction, then this center of mass would have moved in a straight line and it would have gone down. So you can imagine that if center of mass was moving straight down, this point of the ring will have a tendency to slip backward direction in this direction. So that means we can say that as the ring is released, the tendency of the friction force will be like this. I mean the friction will be applying a force in the leftward direction on the ring. So let us approach this question. Suppose this is the initial setup and you know that the center of mass of a ring is inside by how much? Let us call it x. We know that x is 2r upon pi. 2r upon pi, where r is the radius of the ring. Okay. Now, as the system is released, what are the forces acting on it? First force is the weight force mg. Let us say mass of the ring is m, then mg is the downward force acting on the cm. Another force is the normal reaction by the ground n. And we have already discussed that the direction of the friction force F will be towards left. Okay. Now under this situation, you can very well imagine that this whole ring will have a tendency to rotate like this with some initial angular acceleration alpha about this point of the contact. And this is all because of the friction. If there was no friction, then the ring would have simply slipped over here and rotation would not have been possible. So you see over here that alpha is the angular acceleration. Now, if you draw this is the CM, let us call it O. This is O. Okay, this point. And this is point P. Now, we know that this system is rotating with angular acceleration alpha. That means what is the acceleration of CMO? It will be something like this, A. Let us call it A. And A is equal to R alpha. A is equal to R alpha. And if this is X and this is R, then what is OP? OP is under root R square plus X square. That means A is equal to R square plus X square times alpha. Okay. Now this A will have two components. One in the horizontal. Let us say this angle is theta. Then this is what? A cos theta. And other is the vertical component, which is what? A sin theta. A sin theta. Okay. Now you see if this angle is theta, then this is also theta only. Now you apply the torque equation. Torque is what? Tau. You see about point P, what is tau? Tau is only due to the weight force because friction and the normal reaction are passing through it. So tau is mgx is I alpha. I about P. IP times alpha. I about P is what? I about P will be I about this point is what? Mr square. So mr square plus md square, where d are. So IP is nothing but 2mr square. Okay. So tau is what? Tau is mgx is equal to 2mr square times alpha. Alpha you take it from here. So alpha is what? A upon r square plus x square. Okay. Now if you just cancel m and all, then what you get? You get simply gx is equal to, you get what? You get gx equal to 2r square A upon under root r square plus x square. Okay, note this equation. Now you have got the angular acceleration and everything. Now let us apply the vertical and the horizontal balancing of the forces. You see in the what you see why this acceleration A cos theta is component is coming. Who is giving the an acceleration in this direction? It is obviously the force, frictional force. So we can write what? F is equal to let us write it here. F is equal to ma cos theta, ma cos theta in the horizontal direction. In vertical direction, you apply what is the force? Mg downward, n upwards. And what is the downward acceleration? A sin theta. So write it. Mg minus n is ma sin theta. Okay. Now, in limiting case, what is happening? In limiting case, f will be mu times n. F will be mu times n, and we are interested in the limiting case only because we have to find the condition for which it just slips. Okay, and whatever mu comes, we will have that mu as the minimum mu needed. So we will put mu over here, and this will give the minimum value of mu needed for no slipping to occur. So write it over here, mg minus n, put n in terms of this, you get what? You get mg minus n from here, ma cos theta upon mu is what? Ma sin theta. And from here you can see also, if you watch it over here, what is happening? You see tan theta is what? Tan theta is x upon r. That means cos theta is what? Very well, you can say cos theta is r upon r square plus x square, and sin theta is what? Sin theta is x upon r square plus x square. So if you use these values over here in this, you will get a is equal to what? G by 2 sin theta upon cos square theta. This is the relation between a and g. Okay. Now from here you write, if you take the everything you rearrange, you get mu is equal to ma cos theta upon mg minus ma sin theta. This is the limiting case. Now you put all the values and then you get what? Mu is equal to, you see a and g are related, so you put this equation in place of here, you will very easily get a mu is equal to nothing but tan theta upon 2 minus tan square theta. M and m will cancel and everything will cancel. So this is the final equation you will get in terms of for the mu. Now if you put tan theta, you have already seen what? Tan theta is x upon r and x is 2r upon pi. That means tan theta is what? Tan theta is what? X up 2 upon pi. And if you put the numerical value of this in this equation, then you will get mu very nearly 0.4. So this is the answer. And you see, it was asking x upon 10 as the value of mu. That means x is equal to 4 is the answer. So I hope it is clear, and let us see the next question. In this question, the question says that there are two identical balls of radius r and mass m, and another small ball of radius r by 2 falls down symmetrically on the two balls. Okay, so that, and they are connected with springs, ideal springs with force constant k. And what is the question? The ball strikes with velocity v naught as given over here, and it comes to rest just after the impact. This is very important. It comes to rest just after the impact. Then you have to find the maximum compression in each spring in centimeters. So what is happening over here? As the ball comes, it collides, it gives some impact force on these two balls, and as there is no friction on the ground, this impact force will tend to give a velocity to this ball over here and this ball over here, and because of this velocity, the springs will get compressed by some distance x, and this x we have to find. So let us do it formally. Suppose this is the condition just before the collision, and here you can see the triangle is there, and just during the collision, let us say the collision is happening in a very small time dt. Whenever there is an impulse force or a high impulse, then you try the approach I am telling, the problem will become easy. You just focus and concentrate in a very small time interval dt. Take it as a finite time and apply the usual dynamics equation. So in the very small time dt, when the collision is occurring, let us say the forces, the interactive forces which are occurring between the balls is F. That means this ball is applying the force F like this on the smaller ball, and symmetrically the other ball would have applied the force F in the very short interval time dt. That means the resultant force which was applied on the ball was in the vertical direction. And if this angle is theta, then this force is what? 2F cos theta, isn't it? This occurred in a very short interval of time, and we know what F dt is. Impulse is the change in momentum, delta P. So here total force is what? 2F cos theta. So 2F cos theta dt is what? Change in momentum of the ball, and we have been given that the ball comes to rest just after the collision. That means initial velocity was v0 and final velocity was 0. So what is the change in the momentum? Change in the momentum is nothing but m, capital M times v0, because final velocity is 0 just after the collision. So this is one equation. 2F cos theta dt is equal to mv0. Now focus on this ball. Here also, if this was the force F, then the small ball would have applied the equal and opposite force in the backward direction, isn't it? F on the bigger ball. So this ball would have done what? It will have a component in this direction. So here you see, if this angle is theta, so this component, this horizontal component will be what? This will be F sin theta, isn't it? And it happened for a very short interval of time dt. In this dt, spring would not have been compressed by a considerable amount, so we neglect any force by the spring during the time dt. So let us consider the impact of this F sin theta only. So F sin theta times dt, which is the horizontal impulse given to the ball by this ball. This impulse will be what? Again, change in the momentum. Initial velocity of the ball was 0. Let us say the final velocity of this ball became v, capital V, just after the collision. That means what is the change in momentum? Change in momentum is nothing but m times v. So this is the second equation. Now you simply do what? Divide both these two, and you see very easily you will get the answer. So here if you divide, you get what? F sin theta upon 2. That means tan theta upon 2. F dt will cancel. It will be v upon v0. That means v is what? V is v0 tan theta upon 2. This is the velocity of the ball v over this side, and symmetrically this ball will have a velocity v. Now very simply we can see that the energy conservation will be applied, and if the final compression of the spring is x, then we can have half mv square is half kx square. And if you put this value over here, you know v is given. Tan theta is very easily you can find. You see, you just draw the triangle. Here you see tan theta will be what? Tan theta is from this triangle perpendicular upon base. Perpendicular means this distance is what? R. And or let us say this will, let us not write tan theta, we'll write sin theta. Sin theta will be what? Perpendicular upon hypotenuse. Perpendicular is R and hypotenuse is R and R by 2, that is 3R by 2. So sin theta is 2 by 3. Accordingly, we can find the value of tan theta as 2 by root 5. Tan theta is 2 by root 5. So here you get what? V is equal to what? V0 by root 5. V0 by root 5. So you put over here, you get what? Half m. V square means V0 square upon 5. This is equal to half kx square. You have been given in the question value of m, V0 and k. So putting the values very easily, you will get what? X is equal to 8 centimeter as your answer. So I hope you got the concept, and if you have any doubts, any queries, please feel free to ask in the comments. Thank you.